Okay, so the last thing we're going to do for this unit is proving lines parallel. It's not particularly difficult. It's just because we're not really doing anything different. So I'm just going to add this on. So first thing we're going to talk about is, because we're going to talk about this with proof, if I said if A is equal to B and B is equal to C, then what must be true? Well, then A must be equal to C. That's not, I'm going to do something exciting. I'm going to do sparkly. Okay. So we're going to talk about corresponding angles postulate. So basically, we know that if lines are parallel, that, corresponding alternate interior, alternate exterior angles are congruent if lines are parallel. Well, the reverse is also true. So basically, if I know my corresponding angles are congruent, then these lines have to be parallel. So P, so if this angle, if angle 1 is congruent to angle 2, then L must be parallel to M. So corresponding angles are congruent, there's my congruent symbol, then lines are parallel. I'm going to write the symbol. Okay? Converse of alternate interior angles theorem says if your alternate interior angles are congruent, so we're going to call this angle 1 and angle 2. If angle 1 is congruent to angle 2, then angle L has to be parallel to M. Okay, so if alternate interior angles are congruent, then the lines are parallel. Converse of alternate exterior angles theorem says that if alternate exterior angles are congruent, so 1 and 2, then L must be parallel to M. So if angle 1 is congruent to angle 2 here, then L must be parallel to M. So it's not much different than what we've been doing. It's just that questions will be asked are a little bit, the questions that will be asked are just asked in a different way, but it's basically the same process. So, and if consecutive interior angles, now that's a little bit of a different relationship, and that's one of the things that you need to remember. Now we're talking about these guys right here. Well, they're not congruent to each other. Well, what do they have to be? They have to be supplementary. So if angle 1 and angle 2 are supplementary, then line L is parallel to M. Okay, so that's supplementary. Then the lines are parallel. And of course that symbol means parallel. Okay, so what I mean is it's going to be asking the same questions, and you have a little bit of practice with this, but you can work on work on the review after this, because you really don't need any more. Which of the following conditions verify that P is parallel to Q? So it says, if I tell you that angle 6 is congruent to angle 12, can you say that P is parallel to Q? Well, for sure. Why? Because these are, so you're going to say yes, because they're corresponding angles. The corresponding angles are congruent. So that's for sure, yes. Okay, I'm going to stop using the sparkly pen. All right, now we say 8, so angle 8 and angle 16. Well, is that a special pair? Well, 8 and 16 are corresponding, or also, no, oof, geez Louise, my brain, if it wasn't screwed on. So 6 and 12, I misspoke. So, all right, and I'm not going to start this video over again. So 6 and 12, these are alternate interior angles. So you're going to say yes, because they are alternate interior angles are congruent. Then lines are parallel. Okay, so because they're alternate interior and they're congruent, then those lines have to be parallel. So again, the next thing is 8 and 16. You're going to say yes for those because they are corresponding angles are congruent, then the lines are parallel. It says 6 and 7 are supplementary. Well, let's look at 6 and 7. So 6 is here, 7 is here. They are consecutive interior, and we know if consecutive interior angles are supplementary, so we'd say yes. Actually, sorry, this is a trick question. So it says, and I should have stopped, so 6 and 7, if they were asking about T and R, I'd say yes, but no, because angle 7 is not on, or they're both not on, none of the angles are on Q. So it doesn't have one of those relationships. 6 and 7 being supplementary, and I tricked myself, would mean that R would be parallel to T. Okay, 7 and 10. So let's look. So we have 10 is here, and 7 is here. Well, 7 is on P, 10 is on Q. So they are consecutive interior angles on both of those lines. So I would say yes, because if consecutive interior angles are, and actually, you know what, we'll shorten this because you guys can do that. Yes, you're going to say yes by consecutive interior angles theorem that just states if consecutive interior angles are congruent, then lines are parallel. Okay, sorry, just totally botching this today. All right, let's go to 2 and 4. So angle 2 and angle 4. Well, they're only on P, so we're going to say no, because none are on Q. Okay, 11 and 13. So 11 and 13, no, those are vertical, and vertical is not a way to prove lines are parallel because neither of them are on P. Okay, let's look at 1 and 15. Yes, those are alternate exterior. So yes, and you're going to say converse. Sorry, and I should have wrote converse here, but we'll get into that. Oh, geez Louise. Converse of alternate exterior angles theorem, okay, which is that what's up there that just says that if alternate exterior angles are congruent, lines are parallel. And last but not least, 4 and 16, no, they have no relationship. Okay. All right, last two are pretty simple. It's a find x, so L is parallel to M. Well, if L, it's just saying that if L was parallel to M, then this angle and this angle would have to be congruent to each other because they're alternate exterior angles. So you just set it up. So it's going to be 4x minus 10 should be equal to 3x plus 10. Okay. I'm going to subtract 3x from each side. So it's going to be x minus 10 is equal to 10, add 10, add 10, x is equal to 20. And then here, if these two lines were parallel, then these would have to be supplementary. So I wrote 6x. 2x plus 6 plus 130 would have to be equal to 180. Okay. And so this is going to be 2x plus 136 is equal to 180. 2x is equal to 44 divided by 2. X is equal to 22. So that's how you do those. Just really simple and kind of straightforward.